When we talked about the properties of the carbonyl groups, we said that because of the difference in the electronegativity between the oxygen and carbon, the oxygen will always have a partially negative charge, while the carbon will always have a partial positive charge. So this bond is a polar bond, and the carbon that is deficient in charge, which is partially positive, deficient in electrons, this carbon will be subject to attack by nucleophile. So you can, if you have a nucleophile with a negative charge, it can attack this carbonyl carbon. The carbonyl group can easily be attacked by a nucleophile, and here we can add um, nucleophiles to the double bond. So you can add the nucleophile to the carbon, and if you have hydrogen in the media, it can add to this oxygen. So it's an addition reaction. Here, it's not a substitution. We don't have a leaving group here that can leave easily. So the reactions of the carbonyl compounds are just the nucleophilic addition reaction. This is different from the alkene. So if we remember that for alkenes, we had the C double bond C, and we said it's not a polar bond because the two carbons have the same electronegativity. There is no partial positive or negative charge. So the addition for the double bond here was electrophilic addition, because you need to have an electrophile, something that has a partially positive charge that will first be attacked by the double bond. Then we add the nucleophile to the other side. So this is the difference between the double bond in alkenes and the double bond in the carbonyl compounds. Again, when I'm talking about carbonyl compounds, I'm talking about aldehydes and ketones. So the properties, chemical properties of aldehydes and ketones is different from the chemical properties of carboxylic acids and carboxylic acid derivatives. They will undergo a different type of reaction. None of these is actually the addition to the carbonyl group. It's going to be a different type of reaction, which we will talk about later in this lecture. So the first type of reaction is basically the nucleophilic addition to the carbonyl group. The second type of reaction, which we already talked about, is the reduction. So we said that we can reduce aldehydes to give us alcohols, and we can reduce ketones to give us secondary alcohols. Also, there is the oxidation, so we can oxidize the aldehydes to give us carboxylic acids. So let's first start with the nucleophilic addition. So the nucleophilic addition can occurs with both aldehydes and ketones, both which have the carbonyl group. It involves addition to the carbonyl double bond. So we're going to add a nucleophile to the carbon, and then we can add hydrogen to the oxygen. Unlike alkenes, as we said, they will be attacked by nucleophiles, not electrophiles, because alkenes were attacked by electrophiles. And if you remember, for the alkene addition, it was electrophilic addition. So here alkenes, C double bond C, they are nonpolar, so the attacking species is an electrophile, and the result is addition. For the carbonyl, when we talk about carbonyl compounds, it's a C double bond O, and it's polar compound or polar bond, and the addition here is going to be nucleophilic addition. An example of that is the addition of cyanide. So you can talk about any type of nucleophile that can attack the carbonyl group. So let's say if we have the nucleophile here as cyanide like this, so how the reaction will proceed. So now we know that there is a partially positive charge on the carbon and a partial negative charge on the oxygen. And because this is a double bond, the oxygen also can take the two electrons and push them towards itself, completely leaving a positive charge on the carbon. But the carbon will not have just a positive charge like that. So at the same time, while these electrons move towards the oxygen, the nucleophile will attack this carbon. and it will give us a tetrahedral structure with Cr, hydrogen, oxygen with a negative charge, and the nucleophile. Now the oxygen has a negative charge and there will be hydrogen in the medium. So the hydrogen then will react with the oxygen to give us nucleophile, the carbon R, hydrogen if this is an aldehyde, and then you're gonna have an OH. So whatever the nucleophile, whether it's a cyanide group or whether it's, for example, an alcohol or water hydroxyl group, so they will all add in the same way. So it will add to the carbon or electrophilic carbon first. So the nucleophile will be added to the electrophilic carbon, which has a positive charge or partially positive charge, and then the hydrogen will add to the oxygen. So we end up with an OH on the instead of the oxygen. What about oxidation? So there are a different way to differentiate between aldehydes and ketones, because aldehydes can be easily oxidized to give you carboxylic acids, but ketones will not be easily oxidized. So ketones, in order to oxidize ketones, you need to use vigorous conditions and very strong acids, and then it will not give you the acid counterpart of the ketone. Oh no, it will break the chain of the ketones and you will end up with two different carboxylic acids, each with fewer number of carbon atoms. But for aldehydes, you can have straight away oxidation to give you the corresponding carboxylic acids. So completely give you the corresponding carboxylic acid. So for example, if you have something like that, so ethanol, or we can call it acetaldehyde. So acetaldehyde is the formal name of the ethanol. If you oxidize it, you're going to end up with acetic acid. What about reduction? So carbonyl compounds can be reduced either to alcohols or to hydrocarbons, depending on what is the reducing agent we are using. So to reduce carbonyl compounds to alcohols, we can either use catalytic hydrogenation, like hydrogen on nickel or platinum, and then just the hydrogen will be added to both atoms of the double bond. So one hydrogen on the carbon and one hydrogen on the oxygen. So you will end up with the alcohol. If you start off with the if you start off with aldehydes, you will end up with primary alcohol. And if you start off with a ketone, you will end up with secondary alcohol. Another reducing agent we can also use to reduce the aldehydes or ketones into alcohols are sodium borohydride or lithium aluminum hydride. So if you use sodium borohydride or lithium aluminum hydride, they will be a source of a hydride ion. So hydride ion here will act as a nucleophile, and it's going to be and a nucleophilic addition to the double bond. So the hydride will add to the carbon first. So you have the carbon with the double bond. So the hydride will add to the carbon first, and then we need to acidify the reaction mixture. So when we use an acid, the hydrogen with the positive charge then will add to the oxygen. So you will end up with an alcohol. The other method for some examples of that is, for example, if we start off with cyclopentanone. So cyclopentanone here is a cyclic ketone. So if you use hydrogen with platinum, you will end up with cyclopentanol. So from ketone to a secondary alcohol. If you start off with acetophenone, we talked about acetophenone before, so it's a ketone here. If you use sodium borohydride and then you used an acid in the second step of the reaction, you will end up with 1-phenyl ethanol. So this is an ethanol, 1,2, and the functional group here is an OH, and the substituent is a phenyl group on carbon number 1. I have to give number 1 to the one with the functional group, so it's 1-phenyl ethanol. and it's because I started off with a ketone, I ended up with a secondary alcohol. Finally, to reduce to hydrocarbon, we use different reducing agents. So there are two different reducing agents I can use with aldehydes and ketones in order to get to hydrocarbons. So the first reaction is called Wolff-Kishner reaction, and I use hydrazine in alkaline media. So if I use hydrazine in alkaline media, this will not be reduced into alcohol, but will be reduced into CH2. So I convert the C double bond O into CH2. So it will give me a hydrocarbon or alkane. The another reducing agent is zinc with mercury and HCl. This is called Clemmensen reduction, and Clemmensen reduction is another method of reduction that will reduce the carbonyl group here into a CH2. So if you start off with an aldehyde or ketone, you will end up with a hydrocarbon or with alkene.